Hi there, this is Mr. Schnitzia. In this video, we're going to start going through activity 34, where we're learning about prisms and cylinders. Today, in this video, we're going to focus on finding the lateral area and total surface area of a prism and also of a cylinder. So this is on page 495. Let's read the setup of the problem that we're going to solve together. Brooke manages a group of tour guides and bush pilots for a company called Exterior Experiences. Brooke needs to order tents for a large group to be led into a wilderness area to view grizzly bears. Mike is a bush pilot. He is planning to fly a group of junior rangers to a remote lake for a week of camping and trout fishing. They will be sleeping in tents that are in the shape of a triangular prism. The net below is a pattern for one of the junior ranger tents. Examine the two smaller right triangles at the bottom of the pattern. When they are zipped together, they form a triangle that is congruent to the equilateral triangle at the top of the pattern. So the first thing they want us to do is find the area and perimeter of the equilateral triangular base. So that is the area and perimeter for this equilateral triangle right here. So the perimeter is actually very, very easy. That's simply 6 feet plus 6 feet plus 6 feet. So that's a total of 18 feet. To find the area of this triangle is going to be a little bit trickier, and I want to give myself a little bit more room to work this out. So we're going to have to use the area formula for a triangle, which is area is 1/2 times the base times the height. Well, the base is easy enough. The base of this triangle is this 6-foot length along the bottom. But what you might notice is that we don't have a height, so we're going to make the height be this perpendicular distance from the top of the triangle to the bottom. And when we draw that height in, that's going to give us a right triangle about like this. So we know that the hypotenuse is 6 feet. That height is bisecting the base, so this length is going to be 3 feet, and we're trying to solve for the height. Well, since this is a right triangle, we can do the Pythagorean theorem, so that's going to be 3 squared plus 8 squared equals 6 squared. 3 squared is 9, so we have 9 plus 8 squared is 36. We can take away 9 on both sides. So that's going to give us that 8 squared is 27. But when we do the square root of both sides, that gives us that the height is the square root of 27, which we can also write as the square root of 9 times the square root of 3, which we can also write as 3 times the square root of 3, since the square root of 9 is 3. So this height is 3 times the square root of 3 feet. And now we have everything that we need to plug into the area formula. That's going to be 1/2 times the base, which is 6 feet, times the height, which is 3 times the square root of 3 feet. And if we multiply 1/2 times 6, that's 3. 3 times 3 is 9. So that's 9. There's a square root of 3 left over there. So the final answer for the area of the equilateral triangular base is 9 times the square root of 3. Once the tent is constructed, what is the distance between the two bases? Well, that distance is the distance from this equilateral triangle along the top to the other 6 foot by 6 foot by 6 foot triangle along the bottom. So that distance is going to be this length right here, 8 feet. So let's go on to the next page. Let's look at number 4. This says, notice that the lateral faces of the prism form a larger rectangle. Well, in order to make sense of that, we need to think about what it says right here about the lateral area. The lateral area of a solid is the surface area of the solid, excluding the bases. In other words, if we look at this net, but don't include this triangle on the top and the other triangle on the bottom, we end up with this large rectangular region that's made up of 3 6-foot by 8-foot rectangles. So if we put the dimensions of this rectangle together, that would be That would be 8 feet by 18 feet. 18 feet because I guess I cut off a little bit of that one. 8 feet because that's the distance between the two bases, and 18 feet because that's 6 feet plus 6 feet plus 6 feet. So it says, how do the dimensions of the larger rectangle relate to the triangular base and the distance between the two bases? Well, one, the 8 feet is the distance between the two bases. That's right here. The other dimension is the perimeter of one base. Remember that 18 feet was what we got for the perimeter of the equilateral triangular base. The area of the largest rectangle is the sum of the areas of the lateral faces, known as the lateral area. So they want us to find the lateral area of this prism. Well, they got 144 square feet for that. And the way they got that was they multiplied 18 feet times 8 feet. So if h represents the distance between the two bases in a prism, create a formula for finding the lateral area of a right prism in terms of h and the perimeter of the base p. Well, that lateral area for a prism formula is p, the perimeter, times the height, because 18 feet is the perimeter of the base, times 8 feet, which is the height of the prism, the distance between the two bases right here. So now they want us to get the total surface area. The total surface area of a prism is the sum of the lateral area and the area of the two bases. So if we calculate the total surface area for this tent, that would be the lateral surface area, 144, plus 18 times the square root of 3. Where are we getting this 18 times the square root of 3 from? Well, the area for one base was 9 times the square root of 3. We've got a triangular base here up at the top and another triangular base here on the bottom. So that 18 times the square root of 3 is really because we have 2 times the area of one base. So as a decimal, that's 175.177 square feet. And so now if we want a formula for calculating the total surface area in terms of the lateral area, LA, and the base area, B, that would be the lateral area plus 2 times the area of the base. Number 6 says, in the formula you generated for the surface area in item 5B, why is there a 2 as the coefficient in front of the base B? Well, that's because we have two bases, right? Every prism is made up of two bases. We've got this, that's too skinny. We've got this base up at the top, and then these two different right triangles actually are going to zip up together to give us another congruent equilateral triangle. So it's because there are two bases in a prism. To find the surface area of the prism, you need to add the base areas of each base to the lateral area. So now let's look at another example. It says, Mike sleeps in a tent with a different shaped front and back than those of the other tents as shown below. Find the lateral area and the total surface area of Mike's tent, including the floor. Well, we know that the lateral surface area is going to be the perimeter of the base times the height. Well, it might be helpful to find the perimeter of the base. Remember, the base isn't always the bottom and the top. The base is the face that is congruent and parallel to the other base. So since this pentagon is congruent to the pentagon in the back, this is our base right here. So I'm going to outline the base in red. And the first thing that we need to do is find the perimeter of that base. Well, we've got 5 feet plus another 5 feet plus 4 feet plus another 4 feet plus 8 feet. So altogether, that comes out to be 26 feet. And then the height of a prism is always the distance between the two bases. Well, that is going to be this length right here of 10 feet. So we're going to label that our height. So to work out the lateral surface area, that's going to be the perimeter of the base times the height, 10 feet. So in total, that is going to be 260 feet squared. That's good for the lateral surface area, but we also need the total surface area for Mike's tent. So remember, the total surface area is the lateral area plus 2 times the area of the base. Well, let's see if we can't work out what the area of the base is. We've actually got 2 different trapezoids that make up this base area. So the area of the base is going to be 2 times the area of the trapezoid. So our trapezoid is made up of 2 parallel bases that are 4 feet and 7 feet. And then for one of those trapezoids, this length is going to be 4 feet for the height, and the other length over here is going to be 4 feet for the other height. So the area of the base is going to be 2 times the area of one of these trapezoids. Well, what's the area formula for a trapezoid? It's 1/2 base 1 plus base 2 times the height, 4 feet. So if we, PEMDAS would tell us to do what's inside the parentheses first, so 1/2 times 11 feet times 4 feet. And now, since this is all multiplication, we can just multiply this all out. 2 times 1/2 is 1. 11 feet times 4 feet is 44 square feet. So now we have everything we need to find the total surface area. It's going to be the lateral surface area, 260 square feet, plus 2 times the area of the base. The area of the base is 44 square feet. So that total surface area is going to be 260 square feet plus 88 square feet. So that is going to be 348 square feet. So there's a couple other surface area formulas for prism problems that we're going to work out. Here's the check your understanding on the next page, page 497. Identify the figure formed with 2 square bases and 4 rectangular lateral faces. Well, that's going to be a rectangular prism. We could also call this a square prism because it says that the bases are squares. So I'm going to put that as another possible answer. Then they've got a picture of a triangular prism here. So it says identify the shapes and dimensions of the lateral faces. Well, if it's a triangular prism, a nice fun fact to note is that for any prism, the lateral faces are always going to be rectangles. So we've got 3 different rectangles, one that's 5 by 9 here on the left, another one that's 5 by 12 in the back, and another one that's 15 by 5. Oh, I'm sorry, the 15 by 5 one is in the back, and the 12 by 5 one is here on the right. So now they want us to find the lateral area of the prism. Well, remember, the lateral area for prism is the perimeter of the base times the height. Well, what's the perimeter of the base going to be? If the base is a triangle, we've got a side length of 9, we've got another side length of 12, we've got a side length of 15. So 9 units plus 12 units plus 15 units, that's going to be 21 units here, plus 15 units is 36 units. So now we're going to have the 36 units times 5 units for the height. That's this height right here. So that's going to be 180 units squared. That's how we get that answer for part B. Part C says, identify the shapes and dimensions of each base. Well, if it's a triangular prism, we name a prism by the bases, so that's going to have to be right triangles with base 9 and height 12. So what two measures can you add now together to find the total surface area of the prism? Well, we just need to add together the lateral area plus 2 times the area for the base. So we're going to give ourselves some room to work that out over here. If it's a triangle, we know that the base area is going to be 1/2 times the base times the height. So if they told us here that the base is 9 units and the height is 12 units, then the area of the base is going to be 1/2 times 12 is 6. 6 times 9 is 54 square units. So now in order to get the total surface area, that's going to be 288 square units. Well, let's break down how they got that. Total surface area is going to be the lateral surface area plus 2 times the area of the base. So the total surface area is going to be the lateral area we got of 100 units squared plus 2 times the area of the base, 54 units squared, and 180 units plus 108 square units is 288 square units. Okay, last question. If the dimensions of the base remain the same and the height is doubled to create a new prism, what will be the surface area of the new triangular prism? Well, for part E, if the dimensions of the base remain the same, that means that we're still going to have the same 2 times 54 units squared. What would that do to the perimeter of the base? It would keep it the same, so it would still be 36 units. But if the height is doubled, now this height is 10 units plus 2 times the area of the base. So now this new surface area would be 360 square units plus 108 square units. And that is how we would get 468 square units. Okay, so now we're going to shift gears a little bit and we're going to start talking about the surface area of cylinders. Gino owns a company that manufactures cylindrical stuff sacks from water and puncture resistant fabric. Hikers and campers often use these stuff sacks to carry their tents and clothing when they go out on an excursion. The bases of the cylindrical sacks have a 6-inch radius and the height is 15 inches. So it says calculate the circumference and area of one of the bases of the stuff sack. Leave your answers in terms of pi. Well, we know that the circumference area formula for a circle is 2 pi r. So if we do the circumference is 2 times pi times the radius, that would be 2 times pi times 6 inches. That's how we get 12 pi inches. And we also know that the area formula for a circle is pi times the radius squared. So if we do pi times the radius 6 inches squared, 6 times 6 is 36, so that will give us 36 pi square inches. If the sac is laid out on a table, what shape is the lateral surface of the cylinder? Well, that would give us a rectangle. An easy way to recognize this is if you take a roll of toilet paper and you unroll it exactly one time around the roll of toilet paper, the squares of toilet paper that you're left with are in the shape of a rectangle. And what would the dimensions of the rectangle be? Well, this circumference right here, if you imagine unrolling the toilet paper from here to here, this distance one time around the circle would be the length of your rectangle. Well, how long is that? That's exactly the circumference of the circle. So it would have dimensions 12 pi, because that's the circumference that we got over here. And it would also have a height of 15 inches because that is the height of the cylindrical sac. How do the dimensions of the lateral surface of the sac relate to the circular base and the height of the cylinder? Well, we already talked about that. One dimension is the height of the cylinder, the distance from base to base.